Welcome to section 6.0. This is actually kind of a preview before we move into chapter 6 to quick refresh your memory on the properties of exponents. So our goal today is to simplify expressions using the rules of exponents. And we have 7 different rules. The first rule says that if we take any number to a power, we get 1. Sorry, any number to the 0 power, we get 1. So 5 to the 0 would be 1. -2, quantity to the 0, would be just a 1. Our second property says if we take a base to a negative power, we have to take its reciprocal and then the power becomes positive. Okay? For example, for that one, if we said x to the -2, we would take its reciprocal, 1 over x, and take the positive version of that power. Okay? Our third property says if we take a base to a power and the same exact base to a power, we can combine those bases into a single base and we just add the exponents. So x to the second times x to the third, we just add those and we get x to the fifth. Okay? Our fourth rule says just like the last one, but instead of multiplying, we're dividing. Instead of adding the exponents, we subtract them. So if we have x to the 8th and we're dividing by x to the 2nd, our bases are the same, so we keep that base, that x, and we just subtract our exponents. So we'd have x to the 6th. The next rule says if we have a quantity, a product of things being raised to a power, we can just distribute that power to both parts. Okay, so both the a and the b get raised to the nth power. Same thing if we are dividing them and the quotient, that a divided by b, is raised to a power, we just associate that power to both the numerator and the denominator. And then our last rule says if we have a base to a power, so a to the nth power, and then we raise it to another power, we multiply those exponents. So if we have x cubed and then we're going to raise it to a second power, we'd end up with x to the 6th. All right, now the issue when we are using these rules is that often we have to combine several rules into one question. Okay? Also notice that those are properties of exponents. So they only apply to the powers, the base to a power. They do not apply to your coefficients, those front numbers. Directions here say to simplify and rewrite each expression using only positive exponents. We never, ever, ever leave negative exponents. Okay, so we always want to clean those up. Negative exponents, we can just do the reciprocal and it turns them into positive exponents. All right, so as I was saying, when we have coefficients like the 5 and the -3, there are no shortcut rules. It says to take and multiply those, so we have to do that. So 5 times -3 would give us -15. The power part, we have a to the 3rd, and we're multiplying it to a to the -4th. And since they have the same base, we're going to keep that base of a, and we simply add the exponents. 3 plus -4 would be -1. So we have -15 times a to the -1 power. But because it has a negative exponent, we have to flip that. Now, we are only flipping or taking the reciprocal of the piece being raised to the negative power. So that -15 is going to stay there. The a to the -1 becomes its reciprocal, so that a moves to the denominator, and now it's to a positive 1 power. And you can write the 1 in there, but you don't need it. So our final answer would just be -15 divided by a. All right, our second example, we have a quotient. We have pieces on the top and we're dividing them by similar pieces. Okay? Our front numbers, those coefficients, there's no shortcut. It says take 4 divided by 1, we're going to get a 4. For the a pieces, we have a to the 1st, and we're dividing by a to the 5th. Our rule says we subtract those powers, but 1 minus 5 gives us a negative 4, and we can't leave negatives, so we're going to have to flip that over, and it's going to become 1 over a to the 4th power. So our a to the 4th is going to end up in the denominator. So rather than going through all of those steps, it's much easier if we just look at this and say, where do I have more a's? I only had 1 in the numerator and I had 5 in the denominator, so I have an extra 4 in the denominator. Okay? Another way to think of it is you have 1a in the numerator, 5 in the denominator. When you reduce those out, you still have 4 in the denominator. All right, looking at our b term. We have 6 in the numerator, we have 1 in the denominator. That means we have an extra 5 in the numerator. And looking at the c's, we have 3 in each. Well, if we have 3 c's in the numerator and 3 in the denominator, they all drop out. We just get a 1 left, and timesing by 1 doesn't do anything. If you follow the rule of saying just subtract them, 3 minus 3 is 0, but remember anything to the 0 power is 1. So regardless of how you're looking at it, you still would have no c's as a piece in your answer. All right, our next question. It says simplify inside the parentheses first. If we can clean some of that stuff up inside, it's going to make it a lot easier to do the squaring that we have to do on the outside. All right, so let's clean up what we can. The 3 and the 5 have no common factors. We can't divide anything out or reduce that fraction, so we're going to leave it. Looking at our x's, we have 2 in the numerator and only 1 in the denominator, so we have an extra 1 in the numerator. Looking at the y's, be careful here, because that y to the negative 2 in the denominator, you can think of moving that to the top. So we have a y over y to the negative 2 that's equivalent to this. All right, we're flipping that negative exponent piece, taking its reciprocal, which is going to move it to the top. So we end up with having 3 of those y's being multiplied together in the numerator on the top. Again, if you follow the rule that says to subtract them, we have 1 and we are subtracting a negative 2, which ends up being a 3. Okay? Looking at our z's, we have 5 in the top in the numerator, only 2 on the denominator, so we're going to have 3 extra in the numerator. And now I can deal with the square that was on the outside. Okay? So I am squaring the 3, which gives me a 9, and I'm squaring the 5, which gives me a 25. For my variables, remember a power to a power, we multiply. So 1 times 2 is 2. For our y pieces, we have 3 times 2. We get 6 of those. And for our z's, we have 3 times 2, so we have 6 of those. All right, our fourth one here, we have negative 4x to the negative 3, y to the 5th, and we are raising it to the 2nd power. There's a lot of different ways you can go about this. We can distribute that power to each one first. There's really nothing inside that we can condense because they're all different terms, or all different bases, but we could distribute the 2 to everything. Negative 4, when we square it, becomes 16. We end up with a power to a power, so we multiply those. We get x to the negative 6. 5 times 2, we get y to the 10th. We don't leave negatives, we have to flip those over, so this is going to move to the denominator. We'd have 16y to the 10th for the numerator, and we would have x to the 6th for a denominator. Okay, so that's one way of looking at it. Some people like to clean up the negatives first. So another way we could have done this is to say, I'm going to move that x to the negative 3. I'm going to flip it over, change my sign to be positive now, and do that before we do our squaring. But we still end up with the same final answer. All right, our last one here, we have 2r to the 3rd t to the negative 5, we're taking that whole quantity to the negative third power, and then we're multiplying it by r squared times t. So let's go ahead and think about taking that negative 3 to each piece. So we have a 2 being raised to a negative 3 power. We have an r cubed being raised to a negative 3 power. We have a t to the negative 5th being raised to a negative 3 power. And then we're multiplying by an r squared and a t. Okay? Let's clean up our powers. Our first one here, because it's being raised to a negative 3 power, means we're going to have to flip it over. So it's going to end up in the denominator as 2 to the positive 3. Now, 2 to the third power is 8, so we really could clean that up. We'll go ahead and just do that right away. And we're going to have just an 8 in the denominator. Okay? For the r's, we have r to the third to the negative 3. We multiply those, which gives me r to the negative 9. We have t to a power to another power, so we multiply those powers. We get t to the 15th. And then we're still multiplying by an r squared and a t. Okay? Combining our r's, we have negative 9 of them here and 2 more here. That means we're at negative 7 of them. We're just adding those. For the t's, we have 15 there plus 1 here, so we have 16. Again, we never leave negative exponents, so we are going to have just the t to the 16th on top. This r is going to have to bump down to the denominator in order to have a positive exponent. You can put the 1 in front of that t if you want. You don't have to have it. All right, so once again, just make sure that you are combining those rules in order to simplify as completely as you possibly can any of these expressions. Your homework today will be worksheet 6.0. It will be in today's folder.